Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to be talking about cloud functions. And real quick, I should probably point out a lot has changed here. So I've set up a new camera rig that I'm talking to you folks through, and I'm going to be doing some screen switching and all kinds of crazy stuff, and my eyes are going to be in all the wrong places and stuff might be jumping, but we're going to have some fun here. So like I said, today's episode is going to be all about cloud functions. So what we're going to do is help me wrap up the tail end of some work moving the revenue calculation stuff that I've been working on inside of Command, the SaaS app that I've been working on. We're going to move the code from there over to a cloud function. Actually, I take that back. We're going to make the connection between the application and the cloud function. And in the process, I'm going to teach you how to set up your own cloud functions and how to take advantage of this with minimal effort. So what we're going to do is we're going to jump into the code here. And what I've got here is a cloud function. Now, the way that I've organized this, in the past few videos, or pretty much since I started doing these, I've just had the, I guess you call it the, not the monorepo, but the, what do they call those? Monolith. So I've had the monolith repo where I just had all of this code, so the actual command application code at the root of my project. But now what I'm starting to do is think about where could there be bottlenecks. So where could the application unexpectedly just get bogged up with too much work or need too many resources. So what I've done is I've decided, okay, I'm going to split off certain chunks of work that I think are going to be resource intensive off into their own cloud functions. So the core application is still built with PUP and by proxy with Meteor and Node.js, but stuff that I think is going to need a lot more resources, I decided let's put that off into a cloud function and then we'll call that from the application. So where I'm at right now with all this is I've basically said, okay, let me take all the code that I had at the root of the project and I've put that into an app folder at the root of the project, and then I've got a new functions folder which is going to contain, for now, just one, but potentially at some point it could have multiple cloud functions in here. So I'm kind of thinking ahead here and saying like, well, I could see opportunities for other stuff in the future as well. So like I said, right now all I've got is revenue calculator, and what I've done to do this is I've used a service. So I grew really fond of Up, and if you haven't heard of Up is a service run by a fellow named TJ Hollowaychuk, and that name might sound kind of familiar. TJ is, or well, I should say he was super prolific in the Node.js community a few years ago, and then he moved off to work on Go and some other stuff. But it's ridiculous what this guy's worked on. But he has launched this amazing service called Up, which completely streamlines the process for working with AWS Lambda. So AWS Lambda is Amazon Web Services cloud functions offering. So if you've worked with, I think it's like Azure Cloud Functions or Google Cloud Functions, same kind of thing, but it's the Amazon variant of it. And what TJ has done through this Up service is he said like, well, the development experience isn't great, so let me polish it and package it into this nice little service. And the marketing meets the product perfectly. It's really excellent. So I would make the recommendation now, if you haven't worked with cloud functions before and you're just getting started, Up is probably one of the best development experiences I've ever had. And to boot, it's relatively easy to get in touch with TJ. I sent him a tweet, and with less than 24 hours, he got back to me, which was awesome. So I highly recommend this. I am using, so he has a paid service that gives you some extra features for things like encrypted environment variables and things like that. Well worth it. I'm paying for it, and it's awesome. So check this out if you haven't. Really, there's not much to get into. So the core pieces of this that you want to know about are installing the command line tool for Up is done via this curl command. And then if you go through the process of upgrading, you can search this page for Up Pro. He talks about how to do it. And in case you're wondering, there's zero affiliation. I'm just at a fanboy moment with this because it's so well done. So no shilling or anything here. This is genuine. So definitely check it out. Give it an install. It's free to play with. Again, the extra features are through Pro, but I love it. So getting back over to the code, what I did was I basically took all of the revenue calculation code that I had over here in the actual project. So, and it still exists. So I can show you. I put this under API revenue, and then I had this actions folder. This was a project. So I had revenue calculations. Now you're probably thinking, "Good Lord, what is all this?" Well, this is how it started. So I had all these separate files for all this stuff, but about probably 2 weeks ago now, I decided to refactor all these files into one nice streamlined little process. Yeah. So I organized all this, but, and I think I mentioned this in the last video, after that refactor, I started to use this, and it worked great for small amounts of data. I was in a position where it would run just fine. So one of my test accounts only had like maybe a month's worth of data or less. And when I imported that and ran it through this calculator to do the calculations, perfect. It didn't have any hiccups or anything. But the second that I tried to pass the data that was like 2 years old, where it was thousands upon thousands of events, or what I'm technically looking at, when it had that much data, it just choked up. So it would start and it would run, and I'd get my data. So in this case, I'm working with Stripe, where I'm pulling data from. So it would get the data from Stripe, but then as soon as I hit the calculation, it would start it, and then it would just kind of spiral to nowhere. It would literally, no errors were thrown, nothing happened. It just took like, I want to say the longest one was like 5 hours to run all the calculations. So the reason I tell you that is that that's the reasoning behind moving stuff to Cloud Functions. Because I realized, oh geez, I've got this in an application that's also serving up just page requests and database requests for other stuff, and all the CRUD functionality and all the stuff of the application, and I'm trying to have it do I/O out to Stripe. So it's basically downloading a bunch of data from Stripe, and then it's doing CPU intensive work in the form of calculations, and you kind of put on your nerd hat and extrapolate that out, and you're like, whoa, okay, this is going to be way too much on one server, and it's going to be expensive for me to run. So it makes sense to say, take the processor intensive task and move it over to a Cloud Function and be done with it. So I've still got this code here in the main app source code, so I haven't gotten rid of it yet. And in case you're wondering, that's something that I tend to do when I'm working on major refactors. So I never trust refactored code until I'm absolutely certain that the new version works. And that doesn't really hurt you. So you can do your dev, and then once you kind of cross that point where you've done testing, and ideally you have some automated tests as well as just manual testing, once you're absolutely certain that the new stuff works, then go ahead and delete it. And I know some of you may be shouting like, well, don't you do version control? It's like, well, yeah, of course. But it's always good to have the old stuff in context when you're working on a refactor, because then you don't have to fight with going through Git and checking stuff out if you need to do that. It just turns into a mess. So I figure, hey, I can handle a little bit of clutter while I work on a refactor and then get rid of it. So that's what's going on there. So what we're technically doing now, and let's make sure we keep this all in scope. So I'm going to close the app directory and go back to functions here. And so I've done the core work to migrate this over, and it's not perfect yet. So we're going to try and wire this up to the main app. I can't really guarantee that it's going to do what I want it to do, but I got it to a state earlier today where I'm like, yeah, it should work. So before we dig into that connection stuff, I want to walk you through how a Cloud Function inside of Up works. So it's very simple. Technically speaking, it's only two files. So it's this app.js file and up.json. So up.json is describing what your up or cloud function is. So there's a ton of different config that you can do for us. The things that I paid attention to are pretty simple here. So I gave it a name. Profile is saying which Amazon Web Services profile do I want to use. So this is explained in the documentation, but basically this is your AWS access key ID and secret access key ID that you want to do the deployment on behalf of. So basically you can set up AWS IM users. So if you've never played with those are users that you create on AWS that have specific permissions tied to a specific key. So basically, in this case, I have the command up IM user, and that command up user only has the ability to control the things that up asks you to. So I think it's explained in here. Yeah, right here. So all of the stuff listed in this policy, basically when you're setting up your own installation and connecting your AWS credentials, you'll add this policy. And so basically this command up user I've defined on the Amazon Web Services dashboard to say, okay, you can only use these things. And this is what TJ technically has specified as saying, like, okay, this is what he needs access to make all this stuff work. So that's what's going on there. And then I've got regions. This I haven't really messed with yet. I still got to figure out where I want to put all this stuff, but for now I've just defaulted to US West 2, which is like I think the Oregon region for AWS. And then I've got this little section, which is just the Lambda configuration. So here, I'm not going to go too in-depth on this, but this one's pretty self-explanatory. So this is saying how much or how many, or yeah, how do you say that? How much RAM or how much memory do you want to give to this one function? So for each instance that runs, how much memory do you want to allocate to it? And AWS has a bunch of different tiers. Let's see, AWS Lambda memory. Let's see if we can find it real quick. Is it this doodle? No. This is like a friggin' maze through this. Here it is. Okay, so there's all these random kind of memory sizes that you can allocate. So for my needs, I haven't proven this yet, so I still got to test it, but I'm thinking if I give it the max size, it should reduce the amount of time these things need to run pretty low. And so I'm going to try it, time it, and then I'm going to walk it back down this memory stack until I find like a sweet spot in terms of cost and time to run. So for now, I've configured it to this top tier of 3008 or 3 gigabytes of memory. So the other part here under Lambda is this warm true. And this is why up is so cool, or one of the reasons. Which is it's called an active warming feature. So the way that this works is technically Lambda functions have an active state and I think it's called a cold state or a frozen state. So basically if your function is called multiple times within an hour, so if I call it once and then 30 minutes later it's called again, technically that function is still warm or loaded into memory on Amazon servers, so they don't need to spin it up again. Basically, there's no delay in running it. Whereas if you call it once and then you don't call it for 3 hours, then it's in a cold state, so that means that Amazon has to load it back into memory and then serve or process the request that you sent to it. So what's neat is Up has a feature called warming. Yeah, here you go. So this is active warming, and what this does, and I think this is, yeah, so this is Up Pro. So again, worth it, because what this is doing is it's saying instead of doing the cold start, this is going to ensure that it's always warm. So there's no delay waiting for Amazon to load the code back into memory. It's just ready to go. And so what you can do is configure how frequently you want Apex Up or just Up to actually warm the function. So here you can see you can say warm true, so I've done that, and then I'm just accepting the default for now. So it's got how many times do you, or excuse me, how many containers do you want to warm which is 15 by default, and then how often do you want it to try and warm it. So basically, as far as I understand it, it's going to send like a dummy request in such a way to the function and make sure that it stays on and make sure it stays in memory. So definitely worth knowing about. So in terms of configuration for up, that's about it. Another pro feature that exists is the environment variables, and I kind of hinted at this. So there's it's called the up-env feature, and you can see here I've already set just a few things. So what you can do is you can set variables for all of your environments that the Cloud Function is going to run in, or you can do it on a specific environment basis. So here I'm saying I've got this app token, which is how I identify the app to the function. So it's like an API key for my own app to say like, hey, this is a legit request. It's not some random person calling the Cloud Function. And then I've also got the Mongo URL for the different environments. So I've got my development database, production database, and staging database. And so what this is doing is internally, and I think we can see this. I did set up, yeah, I did. So this is assigning to the regular Node.js environment whatever the variable name you pass. So here I've got Mongo URL being set, and so the way that you do this, you basically say up-env add, and you can say where's it going to go. So if you say stage, and then you give a stage name, so like production, and then you just pass your name. So I could say like Mongo _ URL and some value here. So you can do that for a specific environment, or you can just say up-env add your environment variable name, and then same thing. So doing this is going to get it accessible to all environments, whereas doing with the stage flag just does a specific environment. So pretty neat. And what's nice about this is this helps you to avoid having to store environment variables in your source code, which not the best thing to do, especially if you're committing it to version control. Because if your version control gets hacked and your keys get hacked and then everybody freaks out, and the next thing you know, you got to send like everybody in Tennessee $100 because you leaked their credit card numbers or something. Like, not fun. So that's where up-env comes in. Basically what it's doing is it's allowing you to send variables to, I think this is what's happening, to the up servers, and it's being encrypted. And basically when you go to deploy your function, it's going to inject those variables into the application environment securely, so you don't have to stress about that. So again, that pro thing is definitely worth it. Really well conceived. So, all right. So that's the environment variables, and here I'm pulling in the Mongo URL. And so where were we? What were we talking about? I've gone on several tangents here. Let's see. Where were we? Well, let's just keep going. Oh, I was explaining what goes into the Cloud Function. So again, you've got your up.json, and then you've got this app.js, and this is literally the function. So app.js is a convention of up. So basically your app.js file contains whatever code is going to handle that request. And so you'll notice I've got the Node.js HTTP library imported here, and I'm just using that standard create server function, and this is handling my request. So this one isn't too complicated. So in this case, let's comment some stuff out. You can tell I'm getting tired for the day. So what I'm going to do is comment this stuff out, and then we're going to run the dev server. So the nice thing about up2 is that it can help you run your functions locally. So in my package.json, I've got a few different scripts. So I've got a dev script to run the server locally, and I've got my staging deployment command and my production deployment command. And so the dev server, that is technically just with upstart, but because I want to run the function on a different port locally, I've passed this address flag with localhost :5000. So basically I'm saying like run this on localhost 5000 locally when I'm doing my development. So what I'm going to do is say npm run dev here, and cannot find module. I just moved this to a new computer, so I haven't done one of these doodles. So we're going to do that. Oh, that was fast. All right, let's do that again. Still can't find the module Lodash. Well, why would that be? Let's see here. So I've been doing the core development of this on my laptop, and I just moved it here to record this. So hopefully this isn't a total meltdown here, but let's see if we can figure it out. So this is talking about what am I missing here? What am I missing? So let's double check our node modules file. So we're going to see. Yeah, you know what? It does not have it. Oh, I bet you I know what I did. I installed it and I didn't save it. So we're going to do npm install save Lodash. Actually, I can guarantee it because earlier I was looking at my package.json and I used this other dependency p iteration. I was like, that's the only one in there? So now we've come full circle. I do dumb stuff all the time, so in case you're ever self-conscious, don't worry about it. So let's, I think we should be, I see like moments should be in here. I'm a doofus, man. So let's save moment, and I might swap that out so I know moments this pretty chunky dunky library. Now we should be in business. Let's see what happens if I do a dev. Oh, come on. I didn't save anything. Oh, man. So you can tell I'm kind of out of my element with this Cloud Function stuff because I'm so used to, so normally I'll do like Meteor npm. I have a muscle memory encoded here, so I'm on a different planet. So, well, this gives me a chance to kind of explain how all this is working. So basically what I've done is I've completely separated this code from the Meteor app. So like here, this dependency I just installed, Meteor random node is replacing the random package inside of Meteor. So that's a core Meteor package, but doesn't exist for a Cloud Function or a Lambda function, so I have to provide it. Unfortunately, somebody was kind enough to port that code to a regular npm package, so didn't have to sweat too much there. Let's try again. Roll the dice. MongoDB, okay. Hopefully this is entertaining and you're like, oh, well, okay. How about now? There we go. Okay, so when you remove all the buffoonery from what you're doing, and you do, and so I'm doing npm run dev, but again, this is the upstart command, and in this case I've got upstart, and then I'm setting the address to port 5000. So you'll see this output in your console, and this is basically your server console. So if you console log inside your function, you're going to see it here. So what we're going to do is go back over to app.js, and we can see that we've got this response.end, and I've just given a little message here. So if I go over to the browser and I hit localhost 5000, technically that's a lie. I didn't actually do anything, but this is kind of the wow factor of all this. So without really doing any work, and even though I've done work before, literally you could do the same thing with just adding the app.js and the up.json and off to the races. The dependencies are just specific to this code, so that's why I had to do that. So in this case, that's all it takes to get a Cloud Function running. I didn't really do much, and again, this is super well documented over here on the up site. So I think I actually pulled that exact code. Yeah, I did. So I tweaked it a little bit, obviously, but yeah, that's it. So this is all it takes to run your Cloud Function or start your Cloud Function, which is pretty cool. And then from here, it's pretty much sky's the limit. So I personally ran into some things that I didn't expect. So one thing to keep in mind is that AWS, I think this is a Lambda limitation, which is it's running Node, I want to say it was 8.6, something like that. So it's not the latest or most modern version of Node.js running on this, but close enough for rock and roll. So basically you can do, like you can see here, I've got async await calls and all that stuff. So really it's pretty up to parity with most of the code that you write, but keep in mind you're not going to be doing a lot of Babelified code for this. So you're going to just be writing like good old-fashioned require statements. There's not going to be any imports or anything like that. But you get used to it pretty quick. It doesn't really phase you. But aside from that, that's it. There's not really much to this. One thing I do want to call out before we get into the actual coding that's left to do here is MongoDB. So, and this is realistically going to apply to any database. I'm kind of making that up, but in theory this would apply to any database. So the thing I struggled with early on doing this port was getting a connection to MongoDB, and so I figured out that what you have to do is, or well, you don't have to do this, but it keeps the code a little cleaner, is to use async await to do this. So fortunately the core MongoDB, they call it adapter package library. You know, we're all on the same team here. So that core package exports, I don't want to say all, but I'm guessing a majority of the functions as returning a promise. So in this case, this returns a promise, so I can do an await on it. So basically here I do my connection to MongoDB itself. Then I'm saying, okay, which database do I want? And I just found a to-do here. So to-do, make this environment specific. I need to know which database I'm connected to. Actually, let's do it. Let's just do it now while we're talking through this. So you connect to the database. Did I pull the environment? No, that's fine. All right, so we're going to have development. It's going to be the Meteor database. So that's the name of the database in MongoDB when you're working with Meteor locally. That's why I picked that out so quick. And then we've got staging. I call that staging. And you know what? No, I can't get away with that. I was going to say I can just pass the node end variable and say that's the database name, but that's not true because of this Meteor one. What you going to do? All right, so that should take care of that. I can go whoop. Get rid of that, save that. Okay, so we get our connection to the specific database on our Mongo server that we're after, and then we're saying which collections. So basically, I know that these collections are referenced inside of this revenue calculator. So what I did was I just gave myself pointers directly to those. So my code's a little more Sushin. It's not like this long string of nested, or not nested calls, but what are they, chain calls. So all I'm doing is awaiting that connection, and then I grab that stuff and I return it on an object. So I have the core DB if I need access to it, and then I have my collections, and that's it. So back over here in app, I import that, await the response so I get the connection, and then I just pass that through to my function. Probably not the cleanest, but it's doing the trick and it's doing what I want, so I'm happy enough with it. So the last tip I have is, and here if you've been watching these, I'm using the action pattern still. I haven't changed anything in that regard. So what I do is inside of that main handler function, I take in off of options, I have options MongoDB, and I've hoisted this MongoDB variable to the top of the file. So what that's allowing is now I can pass that MongoDB connection and all the collection pointers down to any of the code throughout my function. Again, not the tidiest, but it's doing the trick and it's made it clear enough for me to follow. One note on that, I'm not going to dig into it too much here, but you'll notice whenever I'm doing my calls, I have to put an await in front of them, which means the parent context or function where I call to those queries has to have async on it. That tripped me up, so just kind of take your time with that. You're going to have to do a lot of async await stuff that you may not have expected if you want to avoid a lot of callbacks and stuff like that. So keep that in mind. You're gonna have to deal with that. And yeah, I got frustrated. I got pretty upset. So yeah, that's the big thing to keep in mind is just the order of operations here. Oh, and there is one more detail. So you're dealing with heavily asynchronous code here, so you want to keep in mind that stuff that you expect to be synchronous or behave in a synchronous way may not. So the spot that it got me really upset. It's the most frustrated I've been in a while. I want to say, is it this goober? Yes. No, where is it? Let's look for it. It's worth the little side detour here. Oh boy, now it's looking in the wrong places. Yeah, no, it's in here. Where is it? There it is. Okay, so what I had to do, I have this filter that I use. So this is just a regular array filter. So blah.filter, not that, blah.filter, and then you pass, and then if it's true, you keep it. If it's false, you toss it. So what I'm doing here is I have a filter where I take in an event that I get from Stripe, and I'm trying to figure out, is this the event that I want, or is this a cancellation event? And so in that process, I have to find in the database as well a matching subscribe or trial event, depending on context. Trade secrets. I'm not going to explain it. But the important part is I have to do a query inside of my filter. And so after a lot of head scratching and realizing that the native prototype or prototypal array.filter method didn't really handle the async stuff well, I did a little bit of Googling, and I found this P, or promised iteration package, and it has all of the array iteration, or what do you call that? Array methods. Yeah. Array iteration methods, there we go. So it has all of those methods promisified, so it basically makes it so you can do async await inside of one of those functions very easily. So I didn't really like adding the dependency, but it was one of those things where it was like it got me off the ledge or got me out of the clock tower, so everybody's happy, nobody's dead. It's good. So that's one thing to keep in mind. You may run into issues with synchronicity. So if the code in your Cloud Function depends on synchronicity, so steps happening in order, keep that in mind. And this is one of those unique functions where it cannot go out of sync. It has to be synchronous to work. So my tears are your prosperity. There you go. So let's make sure I didn't break anything. There we go. Okay. So we're going to jump back over here. And I'm realizing that this is actually longer to explain than I thought. And I think it's going to be a lot tidier to just go ahead and say, I'll explain the fundamentals of this Cloud Function stuff and up and all that. And then maybe next week I'll dig into the connection here, because that'll be helpful. So let's see. To wrap up, yeah, let's do this. We're going to create the bridge to the app, and then I think that's going to be it. Yeah. Actually, no, we're not even going to do that. We're just going to handle the authentication, and then we'll call it a night here. Yeah, that makes sense. So let's go ahead and talk about this. So Cloud Functions, technically, I'm the only one that can push it as long as my security is good with my keys. But the kind of universal problem you have is that your endpoints are open. So your Cloud Functions are no different from your REST API or GraphQL API or whatever API. You have to secure it. So here I've just kind of written a dummy function. So I'm not going to show you this because it's a secret key. So what I am going to show you though, I really stumbled over that one. What was I trying to say? So I'm going to show you the authenticate function. I'm not going to show you my token. There you go. So inside of this function, it's going to be very simple. All I want to do is check that the environment variable that I've set as the app token, is what I'm calling it, matches the app token that was sent to me as part of the request. So basically, does this person have the key to the door that they're trying to open? If they do, go nuts. If they don't, block the request. Or actually just end the request in this case. So what I've got here, so I'm calling authenticate immediately inside of this create service. So this is literally where the requests come in. So earlier we opened up localhost 5000 and went to it. So all of this stuff was, actually let's play with it. So I'm going to comment that stuff again, and so we'll save that. Now the one thing you don't get are restarts. So if you make a change, you gotta kill it and restart it. At least so far that seems to be the case. If TJ wants to send me hate mail, by all means. So I've got the function here and it's being called. So what I want to see is, let's get the request log to the console, and then we got to do a little bit of work. So request came in, and there you go. So this is pretty much useless right now, but what's happening is the request comes in and I pass the request and the response handlers into the authenticate function. So that's where I'm going to do my check. So in order to do the check, I was looking at this right before I jumped on. I realized this HTTP create server doesn't parse the query params or anything for you. So you have to check it yourself. So there's this core library URL, and we have to parse request URL. And I know what you're thinking. Does he really use Stack Overflow? It's like, duh. I don't remember all this stuff. You kidding me? This one I genuinely did not know. I was like, I don't know how to do it with the HTTP library. So url.parse. We're going to go back over here, and I think I started. Yeah, I did. So let's do this. Actually, we're going to do this inside of authenticate. Let's keep it tidy. So we're going to pop this up here, and we're going to say, I think this is how this is working. We're going to say query params equals url.parse request.url true. We're going to figure out what that's about, and then I'm guessing, yeah, query. So we've got url.parse. So basically the punchline here is that this is going to parse the query string out of the URL. This true is a little ambiguous, and this is like, this is one of those things, this is one of those rules you don't break. You don't pass booleans as parameters. That's a little funky. Let's see if we can demystify this without too much time wasting. Oh, parse. Let's see if I can type. There we go. Alright, what's up here? Oh, it's kind of buried in here. So you've got URL string to parse. If true, the query property will always be set to an object returned by the query string module. Parse. Oh, okay. So basically it's saying give me back the query string as an object so I can actually work with it. Okay, alright, fair enough. I'm going to be cool. I'm going to back off. I'm going to take a walk around the block, pull myself together. Okay, so we're going to log query params. Hopefully this just works on the first go. So we'll kill that, restart it. And I forgot to save app, so we're going to save that, we're going to kill that, we're going to restart it. Alright, so let's see. We are going to do my favorite turkey. So, what do we get? We kind of got it. So it came through the actual server logs, but it didn't show. So it's saying object no prototype. What? What? Did I type something wrong? Probably typed something wrong. Or somebody's just posting, who'd you? Let's see here. URL parse request URL. Okay. True.query. Yeah, well, okay. Now, did I follow the instructions? Probably not. Let's see. Query data.name. No, I followed the rules here. I'm pretty sure I was a grown adult. Request. I put them in the right order just to make sure I'm not a total doofus. Request response. Yeah, alright, well, we may pause it here, but I can give you a rough idea of what I'm up to. So let's just run this, see what we get, and hopefully it's intelligible. And if not, well, we'll have to noodle. Alright, so we get URL So we do get query. So it didn't recognize this. At least it doesn't seem to have. So, but I'm looking at the 12 docs. So this is where you got to be careful. Let's see. Oh boy. Let's jump up here. There we go. Okay. 8.xlts. So let's just make sure. Here, parse. I'd imagine this hasn't changed much. No. So you've got the URL string, parse query string. Am I missing anything obvious? If true, the query properly set to an object. Okay. Yeah, I'm calling. Wait. This is where you got to be careful. So what's it saying? It's object null prototype. Well, we might be stuck here, folks. Yeah. All right. Well, I'm a sleepy panda. I'm ready to go to bed, so we're gonna call it there. But hopefully that was enough information. But let's do this. So assuming this all came back and query params returned a happy fun object. So let's imagine that query params equals I'm calling it app tokens. We'll say 1, 2, 3, 4. So we'll assume that that's what query params return to us. So essentially all this code is going to do is it's going to say return. So we'll just do it right here. So if query params dot, let's do this. Let's be clean about this. So we're going to say if query params exist and query params dot app token exists. And so am I writing that correctly? Yes. So if query params exist and if query params dot app token, and if we really want to, we'll do that. So we'll say if query params app token, query params. Hopefully this is amusing because I'm getting tired. So we're going to say, okay, if the query params exist, the app token exists, and the app token equals process.env.app token. And again, that's what I set via the up-env stuff here. That's what I've set my app token to. Again, so that way it's encrypted. So basically the idea is request comes in and I expect the app token to be passed to me as a query param. If it equals the one I have stored, good to go. We're going to let the request go through. If it doesn't match, not going to go through. So what I'll do, and let's rewrite this. So it's not going to be a straight return. It's going to be an if. So we're going to say that. And when I have kind of not terribly sloppy code, but stuff that might not be easy to figure out later, what I'll do is I'll say is valid app token or something like that. So same exact logic, but now I've put it in a sentence. It's something that I can easily read. So that's especially helpful if you're trying to debug stuff in a crisis and you don't want to have to reason through stuff like this and get it wrong. That just makes it immediately intelligible to you because you can just be like, oh, okay, if it's a valid app token, do something. So in this case, we're going to invert this. We're going to say if it's not, we're going to say response.end. We'll put the name of the doodle in here and we'll say invalid app token. Please, we'll be polite. We'll say please try again. There you go. So basically nothing's going to happen if the token's correct. It's just going to let it pass through. But if not, it's going to end the response. So in Cloud Function land, this is important. So as soon as you call that, the function's done. That's it. So it's not like a regular Node.js server where you run the server and then you handle inbound requests and you say response.end and kick back to the request, but the server's still running. That's the point of Cloud Functions. It's literally only run as long as I absolutely need to run, and as soon as I get an end, I'm done. Lights out. It's off. So basically, that's what this is going to allow us to do is say, okay, check the app token, make sure that it's correct, and if it's not, just go ahead and end or stop the function altogether and return this message back to whoever's doing the request. So Now we should be able to test this, and it'll bark. So if I go here, let's see what happens. Calculation complete. Am I still calling it? I am. Let me make sure I'm not totally nuts here. Totally tired. All right. I am. I'm tired. Don't listen to me. I'm a fool. But the basic premise is there. I'm obviously going to have to sit here and fiddle with this stuff a little bit. And there's probably something obvious I'm not seeing, but we will come back to that. So I think, yeah, next week what we're going to do is we're going to kind of review where I've gotten with this stuff, and I'll kind of show you what it looks like to connect a cloud function to an app. So literally making this stuff useful for the sake of scaling, which I think will be really helpful to some of you folks. So that's going to do it for me, folks. Thanks for watching. I really appreciate it. It looks like the camera thing worked out. I'm personally loving this. This is cool. Hopefully this adds a bit of polish to this whole thing, and you folks dig it. So that's going to do it for me. As always, if you haven't already, make sure to hit the subscribe button down below, and then hit the bell right next to it so you get notifications as soon as these go live. So that's going to do it for me, folks. Signing off for the HMS Beagle. I'll see you next week.